Right, in this demonstration I'll be showing the key functionality of ExactFlat for Rhino. In this example I'm using the car seat. So we have the car seat made out of mesh, and what we're going to do is I'll simply select the top view. I'll go into wireframe, and we'll go through some of the features of the product. So you can take a look at this mesh. It's pretty good, not bad. Um, ExactFlat for Rhino requires that you have a decent mesh going in. So uh, basically, you want to have a mesh that's uh, not disjointed, that doesn't have triangles broken or flipped over. And how we can do that and test the mesh is we can use our mesh validation tools. So these are our tools up here. We have mesh tools, we have flattening tools, and we have the highlights. So if I go into the mesh tool, the first tool that I have is validate the mesh, selected mesh. Now, a feature in Rhino that I'm going to use is called weld vertices. And weld vertices is actually going to help um, create a better mesh, and it's going to smooth out the bad triangles and disjointed triangles and get rid of them. So what I'll do is I'm going to rectangle select it. I've selected weld vertices. I've typed that in, and now we have our mesh. We have all these points showing that the vertex points are getting ready to weld. I just hit enter on my keyboard. Now those points have been welded. Now if I go to our ExactFlat tool in our mesh tools, the first one is validate the selected mesh. Let's click that. You'll see it says select meshes to validate in our command line. So I'm going to rectangle select again the car seat and simply hit enter on our keyboard. And it says right here all selected meshes are valid. So that's a good thing. One of the other tools, or our next tool, is our Analyze Selected Mesh. So I can select part of the mesh here, and it's going to come up with a mesh quality analysis. So it's telling me I have a vertex count of 367 vertices, and I have a triangle count of 579. So it's a decent mesh. I'll just hit OK here. The next tool that we have is mesh decimation. So decimation is simply removing triangles or reducing the triangle count on a mesh. If I click this, it's going to ask me to select the mesh I want decimated. So I'm going to select the whole mesh. I'll hit enter on my keyboard, and right here it's going to ask me some questions. So I'm going to sew, respect my sew. I'm going to unsew and delete input, and it's asking me what my minimum vertex count. So I don't want 0, but let's say my minimum vertex count, like we have 2,445 vertices on the initial mesh. Let's say the minimum we want is 1,200, or half that. So I'll just hit OK here, and I'm going to so we have our mesh decimation tool comes up. It has a minimum vertex count of 0, which would mean that there'd be no vertices at all. So I'm going to say I want my minimum vertex count to be 1,000. And I'm just going to move this tool over a little bit, and we'll hit decimate. And we'll take a look at what happens to the mesh. So you can see it's already starting to move a bit. It's finished, so it's brought us down to about 1,000 vertices from 2,445. I just hit OK to accept that. So this is our new mesh that's been decimated, and you can see that it's got quite a different vertex count. It's about less than half of what we had. I'll just undo that, and we'll run through some more of the tools. Okay, so the next tool would be our remesh tool. And remeshing, we have two tools. We have just a remesh tool, and we have adaptive remeshing. The remesh tool gives more control to the user. It allows you to put in how many vertices that you want, your ideal target, and it also would have um, information such as number of the edge spacing and things that you can manipulate. Um, the Adaptive remesher is different in the fact that it basically you're allowing the computer to make the best choices for you. So the algorithms are going to create a mesh that they see would be the best mesh available. And how it would do that is it's going to go through, take a look at the planar surfaces. It's going to create a sparser triangle count along planar surfaces, but it'll keep the fidelity on curves. So I'll throw more triangles around curves to keep the curve fidelity. So let's do remesh, just the actual remesh. We'll select the part again. We'll hit enter on our keyboard, and here's our remesh toolbar. So basically we're going to hit sew, respect seams, unsew, and delete input. Delete input, what that does is basically takes, when we have our new mesh, it's going to delete the old mesh that derives the new mesh. So basically here we have a desired vertex count of 300. So I'll go from 2445 vertices down to 300. Let's hit start and see what happens. Okay, as you can see, it's basically gone through. It's reduced 2100 triangles. If I shade this, I'll just hit OK here. I'll go into shade, and you can see it's the fidelity has changed quite a bit. There's some bumps on the topology, and I mean overall the shape looks the same, but it's not as crisp as it was with 2400 vertices. Let's just undo this. And we'll go back in and we'll use our adaptive remesher and show you how that works. So adaptive remesh, as I said, is basically, I call it autopilot. It allows the computer, the algorithms in the software to select the best solution. So what we'll do is we'll just hit adaptive remesh. We'll select the meshes that we want to remesh. We'll hit enter on our keyboard, and you can see this control panel is quite a bit larger, but there's no place here where I can put in my vertex count or anything like that. So we're basically letting the algorithms decide what the best mesh for that shape would be. I'll just hit start on here, and we'll see what happens. Okay, so hit OK. So this is basically the mesh that the computers come up with as a good result. If I go into shaded view, we can take a look at the mesh. You'll see the fidelity is good, very good, and basically it's the triangles are pretty much uniform in shape. All right. If you go to the corners, as I said, you'll end up with uh, um, higher triangles. Like it'll make them a little bit smaller and put more triangles on the curvature of the parts. So that's the meshing tools. Let's go into some of the flattening tools. So if we go into our flattening tools, we go from left to right again. So we basically have select pieces for flattening. Then we have an optimization and our save tool. So basically those are the three things to create a flat pattern. Now, once you have a good mesh, which we have, we would go flatten, we'd optimize, and then we would save out. But we have a lot of other tools here too, so I'll go through those. But let's first go and check out our flattening tool. So once we click it, again in the command line it says select objects for flattening. So I'll rectangle select this object here. Now I'll just hit enter, and I'm going to go to basically my top view, and we'll zoom to extends. So basically here's our model in the middle, and here's all our pattern pieces. What I can do is I'll go into my ExactFlat pattern and highlight that, and I'll turn off my model on my default, and we're going to start using a tool which I call find, or which is called find. and that's this binocular tool here, and that's going to find the pieces that get associated to each other, so how they fit together. So and you'll see if I highlight this edge right above it, right here, it highlights that edge, vice versa. So we know these two pieces go together. I'll just click that. Again, if we click this piece, it highlights that piece there, up there, and we simply just go around and join all the pieces. So I'll just move these out a bit. So once we flatten the pattern piece, you'll see that we've applied a stress analysis, and the stress analysis just basically tells us where the stress on the parts are. ExactFlat for Rhino is a two-stage flattener. The first stage gives us this result, which we call a projected flat. So it's just basically if you had like a can and you stepped on it and it projected that part flat. We have not optimized the piece yet, so we have strain in this. We also, if we zoom in, have what they call flip triangles, and I'll just go into a a rendered view, and this will show up a little bit better. So you can see these X's, and if I zoom right in, you can see this is an edge where the piece is basically rolled over on itself. Uh, this is not good whatsoever for flattening. This is going to give us a very poor result. So I need to get rid of those flip triangles. And I can do that two ways. One is I can use a pre-flattener algorithm called pelt. If I select that and hit the piece, you'll see automatically those flip triangles go away. The other tool we have, which is useful, is our reduce or remove flip triangles, and that'll automatically remove them, but it won't remove. It's good if you have maybe 10 or 20 flip triangles, and in this case we only got 4, so it would work. So if I just click this and hit enter, it gets rid of them. So pelt is good for a large number of flip triangles. Um, the automatic flip triangle remover is good if you have, say, anywhere to 10 to 20, not very many. So we can go around and we'll use our pre-flattener, and all pre-flattening does is basically gets this flat pattern ready for optimization. So it's going to take it another step, another stage down the path to getting flat, and anything we can do to make a nice wrinkle-free stress-free pattern going into the optimizer is going to speed up the optimization time. So in this case, I'm just going to go around and we're going to use we'll try our fracture algorithm. And as I pick these pieces, you can see that it's actually um, flattening them out. Also, what I've noticed is as I fractured them, I've introduced some flip triangles. So let's try our pelt. There. So that's gotten rid of the flip triangles, but as I said, we haven't optimized yet. And we'll go back into our shaded view and I'll show a couple other things. So here, even though we haven't optimized, I'll just show you, and if I go into our legend, which is found under this sprocket, this will give us our legend, and I can see what our legend, this is our strain analysis. So this here, black represents sag of about 0.5%, so 0.5% sag in here. Red up here is 20% stress on the material. We haven't optimized the pieces yet, and we'll do that, and we'll see how much stress or strain or sag we can get out of the pieces. So what we're going to do here is go to our next tool, the optimizer, which is the spring. So it just says pick pieces that you want flattened, which is all of them. Got 7 pieces. I'll just hit OK on my keyboard. And here we have our spring settings. So our spring settings basically allow us to or, pick a material. In this case, I have cotton. I could have a crepe. I could have cord. I could have leather, a laminate, linen. These are our options for materials. I'll just leave it at cotton. I'll hit OK here. Hit OK and accept that, and we're going to go through, and it's going to go through and take the stress out of each one of these pieces. So it's optimizing each one of these pieces, and if you look closely, you'll see that the color is changing. So it's actually going through, it's rearranging um, the algorithms are going through, selecting the material that we have, cotton, and basically creating the best flat pattern, getting zero energy across the pattern piece. Right up here we see the progress, so it's on part 3 or piece 3 and we're at 90%. All right, so we're basically done. The status is done, and you can see that the uh, patterns have changed. It's done its job. We have a little bit of strain on these pieces. I'll just hit OK here, but very little. So that would be about 2% strain on these pieces. Um, Once we've done that, there's a couple other things that we can do. Um, we can go into our highlight tool and we can basically turn on our piece ID. So we've turned on our piece ID, so we have our pieces lined up 1, 2, 3, 4, 5, 6, and 7. What we can also do here is we could join pieces if we wanted to. We can use our um, piece association tool, which will show how these pieces get sewn. So this edge would get sewn to this edge, and this edge gets sewn here. So it basically shows you how all these pieces would get sewn together. We can, as I said before, we can join pieces. So if I go back into my tools and I go to this delete cut, I can go in and I can, as I said, as you select one edge, it'll highlight the other edge. So these two pieces I want to make as one. Just click that, and let's make these two pieces 1, 2. The other thing that happens is I click those three pieces to make one. It updates the piece tags. So now you can see I have 1, 2, 3, 4. Now, once we have this done, there's other things that we can do. So for instance, if we wanted to make a cut in a piece, I can use several different cutters. We have a plane cutter, which allows us to select one edge and another edge and delete the piece like that. Again, as I've done that, it's actually added, piece numbers, tag numbers. So I've cut using our plane cutter. I can also create a, say a spline. Through a piece. I can take this and I can project it to this surface here. You can see it's highlighted in yellow now. And what I can do is I can use our curve cutter to select the model piece. And as soon as I do that, you can see it's turned yellow and it's going to cut through these pieces. So that's good. I'll just hit OK here. And now we've got two pieces. Again, as I do that, the piece identities increase, so it's added two new piece tags. If we want to get rid of that, we can simply just type undo. And we'll do it one more time. Undo one more time. All right, so let's delete this. All right, that's basically some of our cutting tools. The next thing we may want to do is simply create a seam and some notches. So I'll show the notching tool. Notching tool is this tool here, which allows us to open up a notch tag dialog. And I can just add my notches here. Put a notch here, and as you see, as I add a notch here, it automatically updates over there. Put a notch maybe here. So we got notch there, notch there, notch there, a notch there. And let's add a notch here and a notch back here. And so we've gone around, we've added our notches, and let's close the dialog box. The next thing we may want to do is export out the piece to our cutter. So how I do that is I simply use our save flatten piece as a DXF, and I'll just call this seat test.